I don't know if you can see this or not, but I'm bleeding, and it's awful. But it illustrates an important point, unfortunately, which is that violent crime is out there. And this was not a paper cut. You can't cut you can't have a paper cut on your thumb like that. Can you see that? Look at that.
Ouch.
It's like a big gash. It's like a knife wound. And that really is what I want to talk about, the idea of looking at things and searching for patterns. And I think I need a tourniquet or something. Maybe I'll just make a Band-Aid right here. The idea of looking at data. If you have information and you want to analyze it, a powerful way of doing that is looking at the data from an analytical point of view. Hopefully I won't bleed through this tourniquet. And when you look at things from an analytical point of view, you could then search for patterns, the fundamental idea of mathematics, searching for a pattern. Let me give you a very specific example with respect to things that are known as scatter plots, where you're given just a whole bunch of data and you sort of try to look at it and graph it. Look at it. So here, believe it or not, this is so appropriate, is a graph of violent crime. Violent crime. And this is violent crime. Oh, actually, I forgot what this is here. This, I think, is the number of violent crimes per, I think, 100,000, I think. And here, these are obviously the years. Okay, fine. And you can see that these are just the plots. So you can see over here I've got, you can take a look at them. There's the actual raw data that we were given. And I've just plotted each one. So for example, for 1992, I plotted the value that you see there right here. And you can see it's between 700 and 800 and so forth, and I just plotted them. Now, by just looking at those raw numbers, you might not see any kind of pattern. But looking at the picture, you can see not only is it decreasing, which of course the data shows, but also it seems to be decreasing in a sort of linear way. So you might be able to actually try to predict what's going to happen or analyze what's going to happen by trying to fit a line on it. And how can we fit a line? Well, the most naive way, which turns out to actually be not a bad way of doing it at all, is just to pick two values, because remember, two values determine a line, and use those two values to actually figure the line connecting them. So you want to fit two values that are pretty exemplary. For example, if you pick, well, of course, they all look so good, but if you pick, like, for example, this point and connect them with a line, see, that's not so great. There's a little bit of error here. So I spread it out a little bit. What if I pick this point and this point? You see, then if I connect them with a line, it looks actually pretty good in terms of estimating what's going on here. So I'll actually use those two data points. 1993, which, by the way, I'll numerically use as 93. So I'll just use 93 as the number here. So 93, comma, and what does it say there? 747. And then I'll use 97, comma, and what's the value there? If you look at the chart, you see 611. Okay, fine. So using those 2 points, let's find the line connecting them. So we have those 2 points. Let's write them down. Look, can you see? I'm bleeding through my tourniquet. We are talking about violent crime. Violent crime. So we have 93, comma, 747, and we have the second point. It's 97, comma, 611. The first thing I'll do is find the slope. Because remember, the equation for the line is y equals mx plus b. Now, what's the slope? So the slope is the change in y over the change in x. So to find the slope, I have to take, let's say, this y value minus that y value. So 747 minus 611. And then I take this x value minus this x value. Important point right now. If you decide to subtract this y value, this minus that, then you have to use the exact same order, this minus that, for the bottom. You can't switch them. So you pick the point, this minus that, and then take this minus that, and then this minus that. You must do in that order. You can't just switch them around, otherwise you'll get a wrong answer. So now you just compute this thing, and so let's do that. So I've got a calculator here. I would do it in my mind, but I'm afraid that I might bleed right through. So here we go. So you take 747 and you subtract off 611 and you get 136. And on the bottom you get, notice, a negative sign, which is good because notice the slope is negative. Always think if your answer is making sense. If you would have switched by mistake and gotten a positive answer, that wouldn't make sense because the crime here is dropping. So this is going to be negative 4. And what is that? Well, that equals minus 32. So the slope is minus 34. Minus 34. It's there. Okay, so the slope is negative, that's good, and it's minus 34. So we have y, the slope, equals minus 34. So change in y over change in x, minus 34. What's the equation of the line? So it's y equals the slope, which we just computed to be minus 34 x plus b. So now I need the y-intercept, which is sort of hard to read off this picture exactly. However, since I know 2 points that are going to be on this line, if I take either of those 2 points and plug those 2 points in, they must satisfy this equation. So for example, if I let x be 93 and let y be 747, I could then solve for b. And that's what I'm going to do right now. What I'm going to do is I'm going to plug this point. You could have used this point, by the way, and you get the exact same answer, but I'm going to plug this point in. So for x, I'm going to put in 93. For y, I'm going to put in 747, which will equal minus 34 times 93 plus b. So what does b equal? Well, b would equal, well, if I now add 34 times 93 to this, both sides, I see 747 plus 34 times 93. And what is that? I'll do that for you right now. 34 times 93 equals 3,162. And then I add to that 747, and I get that b equals 3,909. Now, when you look at this, you say, does this answer make sense? Does that point look like it's 3,909? No, it doesn't. So what's wrong? Well, what's wrong is, and you can sort of see that with these little hash things, this is not drawn to scale at the beginning. See, this distance from here to here is the same as from here to here, but this is only a difference of 100, and this is 500. So in fact, these axes are way off. And in fact, really, the axes are way off here too, because if this is the start of time, this is 1,992 years later, and this is just 1 year later. So this is not drawn to scale here either. There's a huge gap here. There's a huge gap here. So in fact, this is not going to accurately depict things. Things are actually way, way out and way, way far over. So if you actually were to draw this to scale, you would actually get the correct looking thing. But numerically, it's correct. It's just visually, it's strange because these breaks, not drawn to scale. So now I get the answer. And we can now ask if this makes sense, because we can now use that information to see if we can predict things. For example, let's just try to guess what we think this model would predict for the violent crimes for the year 1998, which would be putting in 98 into here. Remember, I'm just putting in the last 2 digits, 98. So if I let x be 98, 99 rather. 98 we already have. 99, let's try to predict the next one. I'd put in 99 here, and I'd see y equals minus 34 times 99 plus 3909. And let's work that out. So what I take here is 34 minus 34 so you got to do minus 34 times 99, and then I add to that 3909, and I get 543 crimes. Now that actually is consistent with this picture. You can see that I'm dropping, and 543 looks like roughly, if you look at this, that's actually not at all a bad guess. If you figure 1 more year over would be around here, that's actually not bad at all. So that's a pretty good estimator, and we can use this line now to now analyze this particular situation, in particular the situation of a violent crime. Now hopefully my blood and my tourniquet has stopped, but I hope that your thinking about scatter plots and trying to estimate them with a straight line approximation will not stop. And always be prepared. And if I see that person who gave me this cut, there'll be a price to pay. I'll see you at the next lecture, so watch it.